Welcome everyone, and thank you for checking out the Sentinels of the Multiverse Season 2 Kickstarter. One thing that we started on April, I think 25th, about not quite at the midway of the campaign, was to start showing you guys a little bit of the behind the scenes of how we do what we do. In update number 5, we talked about how we finance the project, and today we're going to show you a little bit more of the technical side. So if that's the kind of thing that you're into, if you've ever wondered to yourself what exactly goes into making a deck into a digital deck in Sentinels Digital, that's what we're going to be talking about today. As I'm sure you guys all know, Sentinels content starts, it doesn't start as a stack of cardboard. It starts as a bunch of text probably in a Google document, and then a print and play sample, and then they do go through play testing, and eventually then there's design and artwork. But when it comes to us, it's basically a stack of cardboard cards with the game rules written on them. All the processing power for a tabletop game like Sentinels comes from the brains of the players around the table. So the challenge for us lies in creating an engine that knows all the rules and is able to process them correctly. With me today is John, our Vice President and Lead Developer. Say hi, John.
Hello.
And Jean-Marc, who, apart from being our composer and musician, is also our lead engine programmer. I'm Jeremy, the President and least technical member of the team. And we're going to show you a little bit about how we make a deck today. Tune into some later videos for some insights into the creation of the environments, the UI, as well as the music. So, as I mentioned up front, we start with a sort of a stack of cards, and there's all sorts of things that we have to do to make those into digital games. And I think the first thing we're going to start off with is a bit of a system architecture overview. So, John, why don't you tell us a little bit about that?
Cool. So it'll be easier to understand what's going on when Jean-Marc and I are talking about things if you have a bit of understanding about how the game is put together. So we basically built the game in a model view controller type of architecture. Jeremy should be putting a picture of that on the screen. So the rules of the game are all compartmentalized into the model and the controller. And the model is really what is a game of Sentinels? What is the data? What is the information that's encoded in, this card is here, this ability was used, and so on. What are the hit points of this card, so on. So that's the model. That's going to be in the DLL that Jean-Marc is going to be talking about in a little bit. We also have the controller, which is where all of the logic of how the game works is. So when a card says Tempest deals each target 1 damage, it knows how to make that happen, how to make the changes to the model so that the game state is updated. So all the rules of the game, all the individual effects and logic of each card are in the controller. And it's organized so that each deck sort of has its own bit of logic, potentially, especially for villains. And each card has its own bit of logic. So each card is going to have its own controller class, which Jean-Marc is going to talk about. So that actually, when we first started, we decided on this architecture, and we actually could start building the game without any graphics at all, without anything to see at all, because the game doesn't really need that. All it needs is the data that's changing. That's really what's happening. And so when we started off, the first thing we worked with was the rules and building that DLL, and started with a very simple sort of text harness to output what's going on and input what we want to do. And that sort of evolved into a little more advanced text interface we call the Mega Computer. We'll chat about that in a bit. But those are just views to this system. When the model changes, the controller changes, the view doesn't have to change. It's only whenever the surface changes of these, the interface between them changes that they need to change. But if we update the logic of a card in the rules engine, it doesn't. The view doesn't care about that. It's just going to run that. It's going to run that code through the interface and should work just fine. Now the main view that you are familiar with is the visual of the game, and that's all built in Unity. Unity is available at unity3d.com. It's a freely available game engine. We pay for it because we have the pro version, that mainly lets us get the dark interface, but also has a few more things. There's lots of really cool features, and it's an excellent engine. The one of the major reasons we use Unity because it helps make games cross-platform a lot easier. Your code, you can just write it once, and the majority of your code will work on all the platforms, and there's only a few platform-specific things you need to deal with. They're still non-trivial, but it's a lot less than completely redoing the game for iOS, Android, and PC. And
and I'll jump in real quick. So this is exactly the reason why when we first launched the game, it was only available on tablets. But we did choose Unity specifically because when we pitched Greater Than Games and said, hey, we want to make this as a tablet game, they said, all right, but if you're going to make it for iOS, we want it to be on Android too. And so we chose Unity specifically so that we could make that process a little bit easier. But because of making that decision, it actually made our trip to then bringing the game to Steam that much easier again. So when we launched, it was on tablets, and less than 2 months later, we were already ready to put it on Steam because it was, aside from going through the Steam greenlight process, the technical side of it was very, very strongly helped by having chosen an engine that made it easy.
Yeah, and there's still platform-specific stuff, but it's, I would say, 80% of things are shared, which is really helpful. We also have unit tests, which are a way to essentially write down in code, if I set up the game like this and then do these things, this is what should happen. And that's really useful because we can set that up. We write down if I have a game where Twist Ether is on absolute 0 and he deals damage and I change it to cold and he has null point, then he heals. And great. That passes. We make the code work so it passes. And then we have that test, which we run all the time, every day. And if something happens in the code to cause maybe Twist the Ether doesn't work anymore because of a bug that we introduced, the unit test will fail and we'll realize what's going on pretty quickly. So unit tests are very helpful to make sure that we don't get regressions in the code. It still can happen, but it prevents a lot of them. So we'll be getting more into Unity a little later. But I think what we're first going to talk about, let me just see if I covered all the things in my little section. Yeah, pretty much. The first thing we're going to talk about is what's involved in creating a deck, just sort of a general overview that Jeremy is going to take us through, and then we're going to dive into those specific things.
Cool. So now I'm going to switch over to on the screen here. Now you should be seeing the game. We've got Progeny's deck up in the Multiverse here. And so with Progeny here, we've got all of his cards. You can see his character card. You can flip it over. And as I said up front, a game card basically begins as a piece of cardboard with rules written on it. In this case, with Progeny, we've got at the start of the game, Progeny enters play, etc., etc. The gameplay, at the start of the villain turn, if there are any hero character cards with fewer than 10 HP, Progeny flips. At the end of the villain turn, Progeny deals each hero 2 energy damage. So that's the text that needs to become computer code so that the logic gets processed correctly, and then we know how to do what we do. This is what you guys see. You see it in the game. But the way that we're going to go through how this becomes what it becomes, we start with the original files, then obviously we have the code. We've got some artwork here I'm going to drop up. So this is some of the artwork that Adam creates for us from Greater Than Games, the original artist for the game. He makes us new artwork for the characters that is specific to the video game. And so we get that, we get the code. And then we have music, obviously, for our villains and for environments. Jean-Marc makes music for us, which is going to be covered in a later video as well. And we put all of these things together to create the decks as you see them in-game. It's, a pretty involved process, and there's many stages of testing that happen as we go. We start by testing the code at a very low level. Then we get it into the UI and we test the code, or not the code, but then we test how it actually plays in the UI. Then sometimes we have things where we have to actually test the different graphics and how those are going to be represented. The first example of that was when the chairman had the operative, which was a second character card when we were doing Rook City. That was a whole new system in the UI that had different artwork that we had to make sure that they could flip independently and that they would show up on screen properly. And then all that goes through the beta testing process. With our wonderful team of beta testers who tell us if they see something wrong or if a card's not working the way it's meant to. And then eventually we get it to release. And that is sort of the birth and life cycle of a deck of cards in Sentinels of the Multiverse. So I think now we will switch over to some of the really low-level stuff and talk about the engine a little bit with Jean-Marc.
Okay, so I'm going to step through a little bit what I do when I create a new deck in the engine. So the first thing we need to look at here are the deck lists. These are all the deck lists for all the decks we currently have in the game or coming up. And a deck list is basically just the information about the deck and the cards that it has. I have Wager Master loaded up here, and you can see that for this deck list we say what the character's name is, what kind of deck this is, in this case villain, the expansion that it's a part of, any cards that come out initially in play, and then the rest of it is just information on the individual cards themselves. Obviously, the villain character card has the most text, as you can see here. I won't go over all of this, but it basically covers all the information that you would see on the card itself, including the colors, the hit points, what it says on the front and back, different icons we use, and the difficulty, and even in the opening lines there when they start the game. So for each card, you can see is represented here, and I'll just focus on this one for now. The card, Who Are You Fighting? So this every card has a identifier, and the identifier is only ever used in the code. You never see that in game. And it basically is just a way to make sure that the system always refers to the same card and has some unique way of referring to it. A lot of systems use numbers instead of words, but because we actually have titles to go on, we use those instead. The count is how many of those cards are in the deck. The title is exactly what you see on the screen, and so that should look exactly the same as it does on the real card, unless there's some special text we need to put in there that's interpreted later. The keywords are what you see in the keyword section, in this case ongoing and condition, and the body is what you see written on the card itself. So for this particular card, when this card enters play, each player draws a card and each target regains 2 HP. And then because there's a new paragraph here, we actually close that one off and open up a new line here. If Wager Master is reduced to 0 or fewer HP, the heroes lose the game. And you'll notice that Wager Master is actually in these curly braces because that actually is rendered a little bit differently on the card. It's a bit italicized. Here we have icons, and we have our own special in-code name for what these icons are. And it just basically says, put the icons with these names at the bottom of the small card so that you get a sense of to what they do without reading the full card. At the bottom here we have flavor quotes. Identifier is who is saying it, and then the text is whatever you actually see on the card. And then these BRs just means break the line there, because sometimes the formatting can be very specific, so we want to make sure we get those right. And then flavor reference is whatever comic book it says it's from. So that is pretty much it for the deck list. Is there anything else you guys want me to talk about with those?
I think that covers it pretty well.
Yep,
that's essentially, it's probably 80% just what's on the card, and then the rest is little things we need for the user interface.
Yeah, cool. All right, so from there, we will go ahead and create this card that we're looking at. Who are you fighting? All right, so we have all these different controllers here. John talked a little bit about what the controllers do. We have them organized between heroes, environments, villains, and then a few extra stuff that's, interesting. Just go into here. So, Wager Master actually isn't complete. So the only card that he has is the one we set up for this little demonstration here. Who are you fighting? Card controller. And so basically, when a deck is made, it creates objects, and it creates one object for each card in the deck, and it looks up the identifier and then tries to find some code whose name is that identifier and card controller. And that extends from a base class card controller. And this basically is the setup for any given card in the game. And so we put it in a namespace specific to the character we're talking about, just so that their cards don't overlap. And there are two basic sections to a card controller. There's actually many more for things that have special things, but most cards have either one or both of these. And that is a play method and add triggers. So the play is whatever happens when the card is actually played from hand or put into play or whatever. So in this case, we have when this card enters play, each player draws a card and each target regains 2 HP. So I actually just copied that there. And then in the play method, because this happens when the card is play, I'll just go ahead and put that as a comment. This just kind of reminds me as to what this card's supposed to do, so I don't have to switch back and forth all the time. So the first thing we'll do here is each player draws a card. Now, I happen to know, which helpers I need and like what the code should be and all that stuff. But if I didn't, what I would do instead is just look for another card that happens to have this code. Each player draws a card. So let's take a look at Fleet of Foot. All right. So now we have the code for Fleet of Foot, and as you can see, it's actually pretty concise. Each player draws a card, and then it calls a method called each player draws a card. You may play a card, and then it calls a method select and play card from hand. And this is different because we specify from hand because sometimes you can select cards to play that aren't from your hand. And then each one provides some parameters that are important to that particular helper. And then we have this boilerplate code here, and you may be wondering what that's all about. Basically, the way that Unity handles these kinds of methods and the way that that the unit test does, in our case, or the mega computer, which we'll discuss later, they each use them a little bit differently. And so we wanted to have something, a little bit more elegant than this that could handle both of those cases, but it turns out that it ended up being sort of a cyclical problem. So we just ended up with this, and we basically just copy and paste this wherever we need it. So let's just go ahead and copy this code here. Okay, each player draws a card. Now, Fleet of Foot, each player may draw a card. So you'll notice this optional thing here. Optional is true for Fleet of Foot. But the difference is for who are you fighting, it says each player draws a card. It is not optional. So we'll just get rid of that completely. And there we go. Now, of course, the engine needs to know a lot more about what goes in to each player drawing a card than just calling a method. But we write these for the sake of convenience because it makes our job a lot easier to do. I'll jump into that in a second here. So I'll just go like this here and just separate that bit of comment so that and each target regains 2 HP is its own comment down here. Just so that the code and the comments kind of match up a little bit. So again, I know kind of what to call, but if I didn't, I could look at another card that uses this. So for example, Cleansing Downpour. And here we go. And again, this is pretty clean here. Each hero target regains 2 HP. And then we run this method, gain HP. This hero turn taker controller, CC is hero, and then 2. So what do these parameters mean? Because we've run into them, I'll explain these ones. So the first one is the decision maker. Every time something will involve a decision, we need a decision maker, and that just basically is if we want to determine the order of these targets gaining HP, who will make that decision? So in the case of Cleansing Downpour, it's Tempest. Tempest decides the order in which the targets gain the HP because it's his card and he's the one using his power. The next thing is C, where C is hero. This is a lambda expression. And this basically just means, this C here stands for card, and I'll just write that out there so it's a little more clear. So it's like, which cards are we allowed to heal? So let's look at all the cards, and if the card is a hero, we can choose it. Or, in this case, it is healed. So that just basically allows us to provide a really quick way of providing criteria to this method. Without doing a lot of complicated code. And then finally, this too is just how much HP is regained by this method.
But one nice thing is that that condition can be as complicated as we want.
Yeah,
so it could be every target with odd HP or something like that, potentially.
Yeah.
Wager Master does weird things like that.
Yeah, so if we wanted to add additional conditions, we could just do and card dot card is below, or its below location is below certain card, or there's all these different things, or it's a drug card, or I mean, there's no hero drug cards, but you know what I mean. Or its token pool is a certain amount, or anything like that. So we can make it as simple or as complicated as we need it to be in the particular case. I just use C so that the code's a little shorter. So let's go ahead and copy this here and put it here. Each target regains 2 HP. Now, in the original one, we had is hero, but in this case, we want it to be all targets. So we just change this to be true. So what that means is when it's evaluating a card, and it'll actually only look at targets because those are the only things that can gain HP. So each target, if it meets this condition, should gain HP, and the condition is true. That means all targets gain HP. And then the number is the same here too. Now, in this case, it's a villain card, so the hero, there's no hero making a decision. So this means it needs to be a vote. So we can just put null here, and that means that there's no decision maker and it goes to a vote. But because you have to kind of be careful with where you put null, we actually made this a property called decision maker. And that's just in case we decide to make it something other than null. It'll be easy to do. So this dot decision maker really just returns null in this case. And so for this particular area of the code, that's it. We've just coded this card for that line there. And since I said I would jump a little bit into this, so I will now. So each player draws a card. I'll just follow that. And then this provides a little bit more details as to what should actually happen here. So when it says each player should draw a card, what it actually means is each turn taker, and a turn taker is basically just what we call a player in the game. Because
including
some of
villains and environments.
Exactly, because some of the players, quote unquote, in this case, are just controlled by the game itself. So a turn taker is the hero player, the environment player, or the villain player. So we want to narrow it down to just heroes, because only heroes can draw cards, and make sure they're not incapacitated or out of the game. And then we can optionally provide some additional criteria. So for example, each player who has 5 or more cards in play draws a card. So that could be something we could provide here. Most of the time it's just all players. And then we say how many decisions are we required. If it's optional, then we don't require any decisions to be made. And then we call draw card, and then basically this is kind of like one calls another, until eventually we get to the game controller, and the game controller has all the nitty-gritty logic of everything that should go into it. For example, that little option that you have in the game of auto draw cards or auto decide order of gain HP, it handles all that stuff. And I won't get into that because that, it gets kind of a bit messy and is further along than we really need to discuss right now.
But the nice thing is when you're making the card, you don't really need to know all that. So.
Yeah, absolutely. As you can see here, the code for it is very clean. And in fact, if we take out the boilerplate here, which is just sort of there, but doesn't really match up with the comments, we actually only have just these 2 lines of code. So that is when playing a card. So the next thing is, if Wager Master is reduced to 0 or fewer HP, the heroes lose the game. So I'll just go ahead and copy that. That one actually goes down here into add triggers. Why? Because this doesn't happen when the card is played. This is watching for a particular event, and then if that event happens, it will execute its code. So in this case, we do add trigger, and then we have a whole list of actions. So if any of you are familiar with software patterns, we use the command pattern in ours, and we just call them actions. But it's basically the command pattern. And basically, every action that can happen in the game is encapsulated as an action by itself. We even have a special one for guys here. Basically that just says, okay, run this action, and then for every action, all the other cards have a chance to do something either before that action happens or after that action happens. So for example, redirecting damage or increasing damage should occur before the damage is actually dealt. Whereas a lot of the other things, like whenever a card is played, do this, or in this case, whenever Wager Master is reduced to 0 or fewer HP, do this, that would happen afterwards. So it waits for the thing to resolve, does a check on it, and then sees what happens. So add trigger. If Wager Master is reduced to 0 or fewer HP. So we will respond to deal damage action here. And so if the damage, so DD here means this is the deal damage action that just occurred. So we're allowed to take a look at it and see what happened. So in this case, we'll say if the target of the damage that just occurred is this character card, because we don't want it to see if it's looking at this card, we want it to see if it's looking at Wager Master. So we look at the character card, and this dot character card hit points value oops. There we go. It's less than or equal to 0. So this is the condition. We've just written out the whole condition right here. So when we get a deal damage action, we take a look. Is the target of being dealt damage Wager Master? And if this evaluates to true, it looks at the next thing. Okay, is Wager Master's hit points 0 or fewer? Now, if this is true, it will start running some code. If this is not true, it'll just ignore it and move on to the next trigger or just or action or whatever is supposed to happen next. So if this happens, the heroes lose the game. Well,
Aww.
So again, the response also takes in the deal damage action, because it might need some information from that. In this case, it doesn't, but in some cases it could. And then what happens? Game over. And then so we have a game over, and then we have an enumeration ending result. We may have to add a few more of these for Wager Master because he has so many different conditions. But for now, we'll just take a look at these. So victory always means the heroes won, and defeat always means that the heroes lost. So the normal defeat condition in a game is the heroes destroyed defeat. And that means that all the heroes have been reduced to zero, all the heroes have been incapacitated and the game is done. But in this case, we have an alternate defeat because it's actually Wager Master who has been reduced. And this might actually require some special code now that I'm thinking about it, because the game might end before this even has a chance to check. But those are the kinds of things we deal with along the way. An ending text, actually whatever I put in here is only ever seen on our side because in the game it goes to the ending game screen. So I'll just say Wager Master flipped the tables and caused the heroes to lose instead of win. So again, whenever it's just sort of programmery code, we can just write whatever we want because only our alpha testers will actually ever see that. So that is what will happen. That's the response to this particular condition being true. And then the next thing we do is we provide a trigger type. And the trigger type just lets us categorize what the action is going to do. And this is important more for damage dealing than anything else, because increasing damage, changing the damage type, redirecting damage, all that needs to happen in a particular order, so it needs to run the triggers in an order. Whereas some trigger types we just provide in case they ever matter, but most of them are considered ambiguous and the players get to decide.
I think game over ones matter because they override others, right?
They do. Although, again, in this case, because there's two competing game overs, I'm not sure what's going to happen. and that's not uncommon. It's like, if something brand new comes up in the code, sometimes I just code it as makes sense, run it, and see what happens. And then if what we want to happen doesn't happen, we change it. And so finally, trigger timing. We need to check after he has been dealt damage, because if we check beforehand, he hasn't been dealt damage yet, and his hit points are probably above 0. So we just write that in there. So I just hit build. This is giving you some red text, which means that there might be a syntax error here somewhere.
You didn't get it right the first time, Jean-Marc.
I did not.
Fired.
These are the kinds of unstable employment situations I have to deal with. I write one wrong thing, doesn't compile, I'm fired. And then the next day they're like, nobody else is doing this, so you're hired again. All right.
Or we realize that we can't make the music without him, and we say, all right, I guess we can let you stay.
But no wrong notes.
And also, I would go crazy trying to make guys, and somehow you're still sane.
Yeah, thanks, Christopher. All right. Although Christopher said guys should be the most complicated one that we have to deal with, and I think he's right. So, so there we go. We've just coded this card. Now, we might have to come back to it and make some adjustments in case, oops, I, put the wrong parameter in, or, a special situation requires some special code. There are cards that do that, and it's just like, that's just the way it is. But as far as what I know to code, and what I think should work, this is good. This is where I would stop doing this part and move on to testing. All right. just make a test harness here for Wager Master.
Yeah, so I think just to follow on with the unit testing I was discussing before while you're doing that, the unit test will come in very handy when you're making changes to how the game ends, because a lot of the existing unit tests various ways the game can end. And so, if you're changing certain sort of deep level logic of how we decide the game is over, and you make a mistake, the unit test will tell us right away what's going on.
Yeah. And that helps us so that we don't just assume it works, release it out into the wild, and then all of a sudden every game you lose if you beat the villain. I'm assuming we would find that in testing, but you never know. We just had to
Hopefully we wouldn't even put that out to beta testers.
Yeah. So, usually the bugs that end up being a big problem are ones that don't show up every game, and then somebody finds it, and then somebody else, and then we get to.
Yes. Well, and we have enough players that any situation will happen, but we don't have enough testers for that, and there's no way we could have enough testers for that. So.
Yes.
Yeah, and I mean, this is why even games like, like Halo 5 or any of these other really big games that have these long public betas, that's actually why that's become more of a thing. As games have become more complex, you want to have as many people as possible sort of finding those edge cases so that you can, have a big, larger beta phase before you put it out into the world.
Okay, so now we're going to take a look at writing a unit test for Wager Master, and I won't test the whole card right here for two reasons. One, we don't have Wager Master's character card written yet, so weird things can happen that otherwise wouldn't happen once you did have those. And the second reason is because this could create bugs, and I don't want to debug as part of this video. So the first thing we'll do here is we'll start a new test for Wager Master. And basically we have a text fixture, and that runs a bunch of tests within a given subject matter. So in this case, Wager Master test will test all of Wager Master's cards eventually. And you'll see on the right here, we have all kinds of tests for different things. Promo tests to make sure that promo unlocking runs correctly. Serialization and save load, that's to make sure that when you load when you load an older game that nothing has broken. And then we have one for each villain, and you'll see that there's something up with one of the Cargo Warfangs one. That's what this red here means. And I'll have to take a look at that later. So for now, we're going to do one. So test, who are you fighting? And the first thing we do is we set up a dummy game. So it has to at least have Wager Master in it, but then we can include anyone else we want. So I'll just go ahead and put Legacy and Tachyon in this game, and we'll set it in Insula Prime Allies. I often choose those if it doesn't matter. Just go ahead and start the game, which will do any startup code that Wager Master does. And then we'll set some variables so that we can get each one of them. So Wager Master is the villain, get Legacy, and Tachyon. And there we go. So now we have these characters as variables so we can see what's going on with them. So let's see, what are we actually trying to test? So the first thing we want to do is make sure that when the card is played, each player draws a card. So the first thing we'll do here is we will store how many cards are in each hero's hand. And again, I have these convenience methods for this. So quick hand storage, Legacy, and Tachyon. So basically what this is going to do is, in the back end, just say, okay, I'm going to do a quick check and store how many cards Legacy currently has and how many cards Tachyon currently has. Okay, and then we're going to go ahead and play the card, Who Are You Fighting? And then afterwards, each one of them should have one more card in their hand. So these match up 1-to-1. So Hand Storage Legacy should have one more card, and Tachyon should have one more card. All right. So what else does this card do? Each target regains 2 HP. So we can't check if they're gaining HP if they're already at max HP because they can't go beyond their max. So I will go ahead and set all of their hit points to 20 instead. So do that for Wager Master, for Legacy, and for Tachyon. There we go. So now they're all at 20 HP. And we do the same thing as we did with the hand, except we're doing quick HP storage. And this time we'll include Wager Master in there. We didn't before because he doesn't have a hand to check. And then afterwards, quick HP check. Each one of them should have their HP increased by 2. So as far as this part is concerned, we've pretty much tested everything there is to test. Obviously, there are edge cases like heroes being incapacitated, or them being at max HP, or they don't have hit points because they're flipped. But in the basic everyday situation, we've kind of tested when this card is played. Who are you fighting? These are the changes that should have occurred from before. So yeah, basically there's 3 steps to this. So here, there's before, set the hit points and storage, play the card, and then after, we do the checks to make sure that the appropriate stuff has changed. So now down here, we can run the code, and there'll be output here. So this will show us both whether the test succeeded or failed, and also the output of what occurred, so we can take a look just in case we want to double check. So we got a green, that means the test passed. And then in the output here, the game starts. It goes to Wager Master's start phase, because that's what happens at the beginning of a game. Game controller plays Who Are You Fighting? And the reason this says game controller is because we just wrote code that played it. It played it out of nowhere. It wasn't Wager Master actually playing the card in this case. But that's fine. Legacy draws Heroic Interception. Tachyon draws Quick Insight. So they drew their two cards. So that's why this confirms to true. And then Who Are You Fighting? Caused Wager Master to regain 2 HP, and his HP is now 22. And the same for Legacy and Tachyon. So we can confirm here, and we can see the details here. And now whenever we run this test, that should pass. Just as an example, if I had written this wrong and we were expecting everyone to... actually, I'll go back into the code of the card. So let's say this is what we expect to happen, and I accidentally wrote 3 in the card controller instead of 2. So in this situation, all the targets will gain 3 HP instead of 2. When I run my test, running the test, and you'll see it's red this time. And the reason it's red is because it increased their HP by 2, but our test said by 3, but our test said to expect 2. And then here it gives some output. Expected Wager Master's HP to be 22, but it was 23. And so that gives us a clue as to what we should be looking at. Because if all it said was this failed, that would be very helpful. Then we go back here, and it's like, I put the wrong number there, stupid me. And then I fix that, and then I run the test again, and this time it'll pass. So that's a basic summary as to how we go from writing out a deck to building individual cards to making the tests for them. And now I will pass it off to John.
Awesome. Thanks, Jean-Marc. That is a little taste of what Jean-Marc does probably for half of his time. The other half time is doing music, which we'll have another video about in the future, soon future, near future.
The future.
In many, many
the future.
futures.
It could be right now.
In
maybe
all
the
possible
ideas are-
futures.
All right. So I don't know what's on my screen, but what I'm going to do is basically show the other side. So Jean-Marc took you through the code and the testing and the mechanics of how the deck gets put together that way. But we also need to have it show up on your screen, on your iPad or on your Android tablet or on your computer. And there's a lot of graphical stuff that goes into the game, and I'm going to show you the Unity side of it. So the first stuff I'm going to show you is a bit of the sort of graphics wrangling that we do. Not all of it, but a little bit, to see how you get those cards into the game. I'm also going to show a little bit about. I'll show you how we get some of these Wager Master ones in. I'll show you a completed DLC of Mini Pack 2, so you can see the full scope of what it looks like for a small expansion. And I'll also show you a bit of how the game engine, or we use the word engine, but how the game in Unity works. How does that, you're playing that screen and pages are flipping and cards are moving. How does that actually look to us in the matrix, as it were? So let's get started. So if you take a look at here, on my Mac, we've got files from Greater Than Games. Adam draws JPEGs, which have the artwork for the cards, and they also put together these PSD files, which are essentially what they send to the printer. And so we have access to those from Greater Than Games because they are our trusted partner, and we need them to build the game. So we have these files that we can get the artwork from and get it into the digital version. To do that, we need those trusty identifiers because as far as the game is concerned, a card is only known to it by that identifier. It doesn't really care too much about the title or anything else. It needs to know that one string that Jean-Marc put into that deck list file. That one string is what ties the card together throughout all the living rooms of the multiverse.
Nice.
So this Who Are You Fighting.jpg, you can see this file is named exactly right. And it has to be named exactly right or it won't show up. Similarly, the character card has to be named a specific way, and so on. These files aren't actually finished. Some of we have to bake in some titles and stuff like that, but they are pretty close. So we'll bring them in. I'm going to open up Unity and show you where they're going to go. So we have a project for each expansion pack to keep the files neat and tidy, and also to enable that nice compression we talked about, or we put in an update recently. So let's pop open here. Mini Pack 3. So you can see I've already got some Omnitron 4 files in here, and I'll talk about those. So large card textures are what you see when you bring up a card on the screen full size. And I'll open the inspector here, and we can see, we've got that texture there. It's padded out so that it's square, which is important when you're doing graphics in 3D. Having a power of 2 square texture makes things nice and quick. We also have small versions of the cards. These don't have to be padded out because we actually bundle them together in an atlas. The large files are too large to do that. They're 1024 by 1024 type size images. We can't put those all together into an atlas because it would be too large. But the small versions, we can actually put them together into one graphic that has all the different cards in it. And that helps us draw things onto the screen a lot quicker and save memory.
So I'll just jump in real quick. It's probably obvious from what you're seeing on screen, but an atlas, that's a piece of jargon that non-devs might not know what that means. Basically, it's a collection of graphics into one single texture being essentially a graphic file that we can load into memory once and then sort of pick out pieces of it to show at different places on the screen, different, etc. And so, like, our fonts tend to be handled that way. The card art for small cards is handled that way. Yeah. And it just makes it a lot easier from a memory perspective. We load one thing once instead of loading lots of little things many, many times.
Yeah, an atlas is a collection of sprites into one texture. And so you can see there's three files that go into this atlas. There's the texture itself, which is, if I double click on it, it's just a PNG or JPEG that comes up on its own. And the atlas object here actually knows, the conveyor panels are at this spot, the internal defense grid is at this spot, and is able to pull those out and put them on the screen without getting a bunch of jumbled stuff, which, if you just took, if I click on the material here, the material in Unity is you take a texture and a shader, put those together, that's a material you can apply to any object. Well, here it's putting the shader on a sphere and looks super cool, doesn't it? You can't see that, Jeremy, but imagine putting an Atlas texture on a sphere, and that's what you're saying.
I worked as a 3D modeler and texturer before Handelabra, and so I've definitely seen situations where you have a 3D object of some sort with something on it that doesn't seem quite right, and you can get really interesting effects.
Yeah, and so obviously we don't put these textures onto geometry that isn't. We just use planes basically. So for the most part. So they don't have to work with geometry in the same way. All right, so those are the card textures that we're looking at. There's also some environment pictures here that show up in the background panels. So to save ourselves some time, we do use scripting. And so I have a script that's going to take all those JPEGs you saw that are really big and convert them into the size that we need. So I'm going to run that script. I'm also going to run one that does the small size at the same time. And I probably put something in the wrong folder. Well, that's okay. It's converting Ambuscade because those are all in the same folder. So we can see those are going to start popping up into here. Now that that's done, we've got these files in Unity. Unity picks them up and imports them into the project with its own compression and so on. So you can see now we've got Wager Master's large cards in here, and his small cards are also in here. So they're the same graphic, just at a different size, so that we can put them in the atlas correctly. Let's go ahead and make that atlas. So we're going to select all of his small cards and make a new atlas, an NGUI. Apologies if this text is small. Sometimes, just like, Photoshop and other programs, developer programs seem cooler if the fonts are really small and hard to read. So there's actually no option to make the fonts bigger. We're going to save this atlas out as Wager Master, and of course Wager Master altogether like that is another identifier that's very important. It has to be named exactly right because that's how the game knows to look it up. And then that will save out. My computer's a little slower because it's recording the screen. And now we've got the atlas. We can pull up each sprite and we see they're all separated out. And so that's going to allow us to actually bring them up in the game once we get the rest of the deck implemented. All right, so that's how we get those graphics in the game. That's probably like, one small part of all the things we do to get the DLC form that's ready for the UI. I'm going to open up Mini Pack 2, and you can get an idea of all the other stuff. And remember, this is just a mini pack. This just has one hero, one villain, one environment, but there's still a lot of files. Full expansions have, 3 times as much or more. So now we're going to open up Mini Pack 2. Unity pops into frame here. So we can see in Mini Pack 2, we've got atlases for each of the characters. I'll pull up the inspector here so you can see that in the corner. We've got cutouts. So that's something we didn't mention is we have all the artwork that comes from Adam. He makes this brand new artwork, and that needs to be all put into the game, split up separately. You might have noticed if you look carefully during the game, some characters have special effects that appear on their graphics. So we can look at the Scholar hero turn here, for example. That's his graphic, but we also have another layer of special effects that we put on him. So actually, this is his regular effect. So we take this orange ball, and it gets applied on top with his Philosopher's Stone. When he's damaged, he's got the different graphic, but also different special effects that phase in and out. And you can see his eyes are actually lit up. That's this part right here. It's pretty cool. So Jennifer is the one who mainly does handling all of those because it's not just getting them into Unity. We also have to figure out how we're going to crop the images and make them look right and everything. So there's quite a bit that goes into making that look just right and really cool. We have more cutouts that happen at the start of the game or the end of the game. We have the deck browser, which is all the multiverse information, special ending graphics and files, the environment graphics, again, the cards and the music. And so, all these things come together to, make it a lot more than just the text on the card and the graphic on the card to make it a really cool experience. And that's the stuff that's in this project, the assets, the art assets and everything for the game, is really the program below is really the most of the stuff that's actually specific to any deck in the game. Let's get over now to the actual game project, which is creatively called Sentinels. Do you guys want to pipe in with anything?
I think you're doing great.
Excellent. All right. Spinny rainbows. Let's see if we get open here. I don't think I changed anything. Yeah, it's just the screen. The screen recording is a heavy burden.
Yeah.
All right, so when you open Unity, you have a lovely blank scene here, but that's not what we want to look at. We want to look at cool things. So let's open up the game view scene. So in many, Unity is sort of organized around scenes, and a scene is usually a level in a game. You imagine, something like, imagine if Super Mario Brothers was made in Unity. Each level could be a scene where you would put all the different map, and any special things and all the enemies that are happening in each level and so on. Those could all be different scenes, and you would just load the scene for the level that you want. In Sentinels, it's a little different. We can't make a scene for every possible game because there would be millions and billions of scenes. And so we do things a little more programmatically, where we have a scene that is essentially any game is in this scene, and we configure the scene and load resources based on what we need to happen. And so it looks pretty boring when you first look at it because it's just blank. We have a black screen. We have it set up in a 2D view. If I unpop the 2D view, you can see it's actually in 3D, but we're just, in the bottom here is what you're actually going to see on screen. On the top is what Unity is doing. So let's hit play and see what's happening. I don't even remember what I've got set up here. We have a nifty thing configured where we can just hit play on this scene, and it will go to a certain spot that we've configured for our testing. And that can be different for what I'm working on. John Mark has his own, Jennifer has her own, and Jeremy doesn't do that sort of thing.
Yep.
But I'm sure sometimes you go in and press play and see what happens.
I absolutely do. There have been very few times that I've actually needed to specifically. At one point, I was testing when we were replacing the main menu graphic, and so I would go into there and just push play when it was just to make sure everything was looking the way that I was expecting it to. But that's pretty much the extent of my Unity knowledge.
So here in the bottom is actually, this is the live game view, which is what the game is doing. I don't have my mouse plugged in, so navigating this is really hard. There we go. This is kind of a fun way to see it. So you can see that the game view is here, and there's actually this white thing, which is part of the page flipping mechanism, actually. So I can actually click on these things and use powers and so on. So I'm going to go ahead and use a power for Tempest, and we'll see how the page flip happens, because that's kind of cool when you see it in the 3D view. I'll damage Friendtat. You can see that different elements in the scene view here are happening and popping up in 3D. And I'm going to stop dealing damage. We'll get a card drawn. You can see in the 3D view, hopefully the frames per second is enough. You can see it rotating around and stuff. We can actually pause things at any time in the 3D, in the scene, and see what's going on. So I can actually pause it. I can click on something and look at it. So actually I clicked on the wrong thing. So you can click on something and say, I want to look at that card. Cleansing Downpour, I can search for it. right there. And, I can look at its properties in here and say, oh, maybe something's wrong with how the flavor text is being rendered or something. I can look at that in detail in the inspector here in the hierarchy and drill right down to it. And you can actually make changes. So this is something I'm going to show you in a second. So I'm going to let it continue going. And that is going to go away. And then we're going to get a page flip. After this card draw, flippy. Yeah, so what it does, it's not going to do a page flip yet because it's a hero turn. I'll get to that in a second. So I first want to change something. Let's go back to the 2D view up here because it's a little difficult. Let's grab StealthBot and let's just move StealthBot over there. So there's a depth issue. It's not going to show up in front of Karga Warfang, but you can see you can actually change things in a live way while you're developing in Unity. And that's really helpful, especially for action games and stuff where you can be like, I'm going to change the color of this object and see how it looks in my scene, or I'm going to do this and that. It's still useful for us, but it's a pretty cool way to do things. It's definitely a different way to build games than many other engines. So actually, I'm going to switch this back to 2D view because I've been talking about it all this time, and I'm going to show you what happens in the page flip. So, and I'll do this quick. I'll just skip turns. And then what I'm going to show you after that is just how we set up our testing game in here. And then we're going to have a lot more about how the UI works in a later video we're planning out. So if you're interested in that sort of thing, stay tuned. So here we have Omnitron's turn. I'm just going to skip his turn. So he draws a couple cards. All right, and so what it does here, I don't know if you saw that, but that can go later. What happened there is it actually captures the screen, puts it onto this book object that we have, turns the page, and then it goes away. So it's kind of a little sleight of hand, which is like 99% of video games are sleight of hand. So, all right, so here's the environment turn going, and we can stop that and go. So as you can see, when you stop the game, it goes back to the black screen. There's nothing actually in this scene that knows anything about really any particular game. It knows about how to show damage dealing and that sort of thing, and other generalized things, but it doesn't know anything really specific about Karga Warfang, for example. In this code file I brought up, it's just a quick sort of testing setup that I can use to create whatever game I want. So here I can say I want my game to have this villain, this environment, and these heroes. So let's say I want Le Capitan, and let's have Haka and Captain Cosmic. And we'll take out Omnitron. And we'll take out Legacy. And then let's put in the new environment, Omnitron 4. Should work. Haven't tried it yet. Living on the edge. Here's just a bunch of little helper code. And so this is sort of similar to the unit test, but it's a little more, rough and ready because I can just change anything I want. I can say I want the villain to have 20 hit points. I can say start with this card. It's used for more like I get a bug that says, someone reports a bug about a certain card in a certain situation. I can use this code to set up that situation and then run it and see if I can replicate their problem in a little more of a live fashion. Because some bugs aren't anything we can fix in the unit testing. It's stuff that is a UI bug or something like that. So I'm just going to say start at the start of the villain turn because I don't remember what heroes I put. I guess I put Captain Cosmic. We can start on Captain Cosmic's turn. Then I'm going to go back to Unity. It'll have to do a little compile because I just changed the code. You notice that the code is in C#, just like the engine, which makes it easy to go back and forth. You can actually use other languages in Unity, but C# is the best one that they have available. And I like C#. So we're going to play this scene, if my computer can handle it. All right, we're going. So here you can see those that setup I put is in the game. So Captain Cosmic is here, and Omnitron 4 is live. And so we can do things like, let's take a look at what Omnitron 4 looks like. We'll just turn off more things. Let's turn off Le Capitan. Let's turn off Tempest, Unity, Haka. Well, I guess that turns off the background too. Got to be careful with playing with things live, but the nice thing is in play mode, when we're playing here and we change things, it doesn't save, so it won't break anything. And let's see if Omnitron 4 has a card that works properly. Testing live on film for the first time, Jean-Marc. The mega computer.
Okay. If it's did you just build a DLL?
Pretty recently.
Okay.
We have a resource recycler. At the start of the villain turn, stuff happens. Anyways, this is still really early in development. We haven't done a lot of testing of these decks and stuff, so that card actually doesn't really do much. So there you go. That's about all I think I have to show about Unity. Let me just check my script. Yep, that's it. So I'll get rid of that. So yeah, so thanks for tuning in. I'll put it on the main menu scene so you can see that, because that's exciting.
Yeah, so that was a little bit of another look behind the scenes, getting into real nitty and gritty. I know that there's a lot of Sentinels fans out there who really like the nitty gritty. This is a game that has a lot of very strategic discussions happening about, if this card is in play and this happens, what happens next? And we basically play that game, but like times 10. That's how programming these decks basically comes. And when I say we, I of course mean absolutely everybody but me, because I don't do that part. And I think I'd go crazy if I did. But this is why, like when people say, I know there's been some discussions in the past, like, oh, it must be so easy for them now that they built the engine. Just implementing a deck is just a simple thing. Or someone might say something like, I can't imagine why there aren't mods for this game. Now that they built the engine, it's just a question of dropping in new cards. And so I hope that gives people some deeper understanding of why that isn't exactly the case.
Yep, and one thing we didn't really get into is there are certainly cards and decks that require us to build new UI elements. Mm-hmm. And that's come up in pretty much every expansion. In the last expansion, you can think of the Bloodsworn Colosseum, has a bunch of new UI aspects that need to be built with title cards, favor, all that stuff. Skyscraper has her own special character cutout handling with her different sizes, including the little tiny version of her on her character card. And so there's lots of different things that go into each expansion that aren't necessarily obvious, but there's a lot to it.
Definitely is. All right, well, as I said at the top of the video and a couple times throughout, this is just the first. We're going to be doing a couple more of these look behind the scenes, hopefully, as the Kickstarter continues. So please to keep a lookout for that. We're hoping to still get you a little bit of info on how Jean-Marc composes the music. And then we're also going to have another video that talks specifically about our environment process, how we create the 3D environments for the game. And that might not be all. Who knows? It depends on how much time we have and how things are progressing. But we know that some of the fans really like this kind of stuff, and so we thought we'd put something together for you. So thank you so much for joining us. Thank you for taking a look at the Kickstarter. We really hope that you decided to back us to help make Season 2 a reality. And stay tuned to the Kickstarter page over the next few weeks, and there will be more fun stuff to see. So I guess we're signing off from the Multiverse. Thanks, everybody.
Thank you.
Thanks.